Why didn't the articulated dozer, a machine with seemingly superior design, ever dethrone the classic track-type dozer? Was it a flaw in engineering, a miscalculation in economics, or something even more fundamental? Get ready to uncover the surprising truths and often overlooked factors that sealed the fate of these unconventional earthmovers. To the casual observer, the articulated dozer looks like a masterpiece of versatility. It's got the massive blade of a tractor, the fast-moving wheels of a loader, and a pivot point in the middle that makes it look like it could dance around a job site. In the 1970s, the industry's biggest players, Caterpillar, Fiat-Allis, and John Deere, weren't just interested, they were convinced. They saw a future where the slow, grinding noise of steel tracks was replaced by the high-speed hum of rubber tires. But as we stand here today, the track-type dozer remains the undisputed king of the dirt. The articulated dozer? It's been relegated to the corners of the industry. To understand why, we have to look past the marketing brochures and get deep into the grit, the grease, and the cold, hard physics of moving the earth. Part 1. The theoretical edge. What made them seem so promising? In the post-war construction boom, the industry had a need for speed. The standard track dozer had one major, glaring flaw. It was slow. We're talking 5, maybe 6 miles per hour on a good day. If you needed to move a dozer from one end of a 5-mile highway project to the other, you didn't drive it. You called for a lowboy trailer, spent an hour loading it, moved it, and spent another hour unloading it. The articulated wheel dozer promised to kill that downtime. With travel speeds of 15 to 25 miles per hour, these machines could literally run across a site. But it wasn't just about speed, it was about the articulation advantage. Traditional dozers steer by breaking one track, a process that scuffs the ground. If you've just spent 3 days compacting a soil layer to perfect density, the last thing you want is a steel track tearing it up just to make a 180-degree turn. An articulated dozer, however, bends in the middle. It walks through turns. It promised high-speed maneuverability on soft ground and reduced site damage that would save contractors thousands in rework. In the early 80s, the market buzz was electric. Manufacturers were pouring millions into R&D. On paper, the track dozer was a walking fossil, and the articulated wheel dozer was the meteor coming to wipe it out. Part 2. Engineering roadblocks, the mechanical Achilles heel. But here's the thing about on-paper designs. The dirt doesn't read the manual. The moment these machines hit heavy-duty applications, the mechanical Achilles heel revealed itself. And it all came down to that central pivot point. You see, a dozer is essentially a massive horizontal battering ram. When a track dozer pushes against a pile of wet clay or a stubborn boulder, that force is distributed across a rigid, solid steel frame and thousands of square inches of track. In an articulated dozer, that entire load, every single pound of thrust, is focused directly on the center hitch pins and the oscillation bearings. It is a massive amount of stress concentrated on a single movable joint. Engineers quickly found that maintaining a tight, slop-free articulation joint under extreme loads was a maintenance nightmare. Once those pins developed even a fraction of an inch of play, the machine's precision vanished. You weren't just pushing dirt anymore. You were fighting a machine that wanted to wag its tail. The cost of line boring and rebuilding these massive center joints often wiped out any profit the machine had made during its high-speed sprints. Then there was the traction problem. It's basic physics. Steel tracks have a massive footprint. They mesh with the ground. Rubber tires, even massive ones, rely on a small contact patch. In perfect dry conditions, the wheel dozer was a beast. But the moment the ground got greasy or the slope got steep, the wheel dozer would sit and spin its tires, burning through expensive rubber, while a track machine with half the horsepower would simply dig in and move the mountain. Part 3. Operational realities. Why they failed on site. Beyond the mechanical failures, we have to talk about the person in the seat, the operator. If you've ever operated a track dozer, you know it feels stable. It's a low-profile tank. But an articulated dozer? It's a completely different animal. Because the machine pivots in the middle, the operator's perspective is constantly shifting. Imagine you're trying to maintain a perfectly level grade. In a track machine, the blade is fixed to the rigid frame. In an articulated machine, if the rear tires hit a soft patch and kick out just 6 inches, your blade angle changes instantly. It requires an insane level of counter-steering just to keep a straight line. Operators hated it. It was physically exhausting. The snapping action of high-pressure hydraulic steering on a wheel dozer can be violent compared to the smooth, predictable glide of a track system. And then there was the versatility issue. A track dozer is the Swiss Army knife of the job site. It can clear forest, rip through shale, push scrapers, and finish graded driveway. The articulated dozer, however, found itself trapped in a niche. It was great for pushing light, loose coal in a power plant, or dry trash in a landfill. But for pioneer work, the raw, ugly job of breaking new ground, it was practically useless. It was a specialist in an industry that demands generalists. Part 4. the economic hammer, cost versus benefit. Now let's talk about the factor that truly seals the fate of any machine, the bottom line. In the construction world, we don't buy machines, we buy cycles. We buy the ability to move a cubic yard of dirt for the lowest possible price, and the articulated dozer was an economic disaster for the average fleet owner. First, there was the purchase price. Because of the complexity of the driveline, we're talking four-wheel drive, massive planetaries, and that heavy-duty central hitch. A wheel dozer often costs 20% more up front than its tracked cousin. But the real economic hammer was the maintenance. Let's talk tires. A set of 4 massive earth-moving tires can cost upwards of $40,000. On a rocky site, a single sharp piece of flint can puncture a sidewall and turn a $10,000 tire into a giant rubber donut in seconds. Tracks are expensive, yes, but they are predictable. You can measure track wear and plan for it. Tire failure is often catastrophic, expensive, and happens without warning. And finally, the death blow, resale value. If you have a 15-year-old Cat D8 track dozer, you can sell it in an hour. Everyone knows how to fix it, and everyone has a use for it. But a 15-year-old articulated wheel dozer? That is a scary asset. Used buyers fear the hidden costs of a worn-out transmission or a loose articulation joint. The depreciation on these machines was, and still is, terrifying. Fleet owners realized that while they might save some time on travel speeds, they were losing a fortune on the back end of the machine's life. Part 5. The undisputed reign. Why tracks remain king. While the articulated dozer was struggling to find its identity, the track-type dozer didn't just sit still. It evolved. The introduction of the high drive, or elevated sprocket system, changed the game. It moved the expensive final drives away from the dirt and the shock loads, making tracks more durable than ever before. Then came the digital revolution. Today's track dozers are equipped with 3D GPS and integrated grade control. They are no longer blunt instruments, they are surgical tools. A modern D6 can finish grade a parking lot to sub-centimeter accuracy at high speeds. The precision gap that the articulated dozer hoped to fill was slammed shut by technology. And we can't overlook the ecosystem. The world is built for track dozers. Every mechanic from Texas to Thailand knows how to service them. Every parts warehouse stocks their filters and idlers. To bring an articulated dozer into your fleet was to bring in an alien, a machine that required different parts, different skills, and a different mindset. Most contractors simply decided it wasn't worth the headache. So what is the surprising truth behind the fate of the articulated dozer? It wasn't that the engineering was bad. In fact, for very specific jobs like moving wood chips or working in high-speed landfill compaction, it is still the best tool for the job. The failure of the articulated dozer was a failure of assumptions. The manufacturers assumed that speed was more important than raw pushing power. They assumed that maneuverability was more important than stability. But the earth is heavy, it is stubborn, and it is unforgiving. It doesn't care how fast you can drive across the site. It only cares about the machine that can dig in its heels and refuse to back down. The track-type dozer didn't stay dominant because of tradition. It stayed dominant because it is the most efficient way to turn a mountain in.